Solve 10 to the 1 minus x equals 6 to the x. Give an exact solution and an approximate solution rounded to 6 decimal places. All right, we'll rewrite this below so we have a little bit more room to work on it. And here we actually have an interesting situation because we have exponents on both sides with variables in them. There's actually two different ways that we can do this problem. I'm going to go through it the first way, and then afterwards I'm going to show a second way that we can do it. So first, it might seem weird, but we can write this in logarithmic form. We're just going to pick one side to be the main exponential expression. So on the left, we have 10 to the 1 minus x power, and that equals 6 to the x. We can rewrite this as a logarithm, as a logarithmic equation, even though we've got this weird 6 to the x over here instead of just a number. If we rewrite this in logarithmic form, we get log base 10, and I'm not going to write the 10, I'm just going to use a common log. Log base 10 of 6 to the x equals 1 minus x. And then we can use a law of logarithms to take this x and pull it out front as a coefficient. This gives us x times log of 6 equals 1 minus x. And now we need to solve for x. What I'm going to do is I'm going to add x to both sides so that all the variable terms are on the left. So x log 6 plus x equals 1. And now it's difficult to combine these two terms with x's because one has a log and one doesn't. But what we can do is we can factor out the x on the left-hand side, writing this as x times log 6 plus 1 equals 1. And then to get the x alone, we divide both sides by log 6 plus 1. And so we end up with x equals 1 over the logarithm of 6 and then plus 1. And we can put the parentheses around 6 just to show that we're not taking the logarithm of the whole thing, 6 plus 1. We're taking the logarithm of 6 and adding 1 to it. And so this is our exact answer. If we enter this into a calculator, you're going to have to be careful how you do this, making sure that you're following order of operations. But you should get an approximate value of 0.562388185, etc. And we wanted to round to 6 decimal places. The 6th decimal place is this 1, and because it's followed by 8, we round the 1 up to a 2, and so we get 0.562382. And that is our approximate answer. But there's an alternate way to solve this as well. When we have 10 to the 1 minus x equals 6 to the x, another strategy that we can use is we can take the logarithm of both sides. So we can take log of 10 to the 1 minus x and have that be equal to log of 6 to the x. And now what we can do is we can take these exponents and bring them out front as coefficients. That was one of our laws of logarithms. So we've got 1 minus x times log 10 equals x times log 6. And log of 10 is just 1 because 10 to the first power is 10. So on the left, we just have 1 minus x equals x times log of 6. And we can see that this is exactly the same as the equation that we got over here. And so the rest of the solution would end up being the same. There's no reason for us to do that again. But this is just another tool that we have If we have exponential expressions on both sides, we're allowed to take the logarithm of each side, and that will allow us to bring the exponents out front as coefficients and proceed from there.